A unit test is a test that verifies the behavior of an isolated piece of code. It can be used to test a single function, method, or class. But what exactly does testing mean here? There are two types of testing. First one is the manual testing. In this case, you write code, develop your app or software, then you test the features and try to find bugs or defects in the app. Second one is automated testing. Automated testing is just a way to prevent the software from expected bugs. But it doesn't mean the software does not have any bugs. It just means the software does not have any expected bugs. Automated testing is generally preferred over manual testing. Why? Let's say you're building an e-commerce app as big as Amazon. With manual testing, you would need to rely on a team of testers to check each feature and component of your app and ensure that it meets the required specifications. This process can be time consuming, error prone, and subject to human biases. On the other hand, with automated testing, you use automated tests to check each feature and component of the app and ensure that it functions as expected. This method is faster, more reliable, and more efficient than manual testing, as it can test a large number of scenarios in a short amount of time and can detect even the smallest defects. In Flutter, we have three different types of automated testing. First one is unit testing. This is what we are going to dive deep into in today's episode. Second one is widget testing, the second episode of testing series. And third one is integration testing, the third episode of this testing series. The question now arises, why do we need unit test? There are many reasons for that. First of all, unit test helps us identify bugs at an early stage, which means it can save a company a lot of time as well as a lot of money. Second reason is when we want to refactor our code, we might get a little scared because it might break certain features in our app. When we have unit test and then we decide to refactor, we have the confidence that if something goes wrong, our unit test will tell us about it. Third reason is that debugging is very simple when we start unit testing, because we can know what cases are failing, and because of that, we will get to know where exactly the bug lies. To understand them even more, let's just dive into unit testing. And the first app that we are going to unit test is a counter application. This counter app is the exact same app that we get when we first create the Flutter project. We'll slowly work our way up towards more complex apps, but first here we'll understand the basics of testing. So let's analyze the app. What have we got here? We have got an increment button. Whenever we click over here, the state of this counter changes. So this is what we want to unit test. But whenever we unit test, there's one thing to keep in mind. Is the code testable? If it's not testable, we have to make it testable first. This code is not testable. Why? Because our application logic, which is this function increment counter, then we are setting the state and incrementing the counter variable. All of that is mixed with the user interface, which is the home page. Since the UI and our application logic are mixed together, we won't be able to unit test it. It's pretty hard, and we can just ease the process a little bit by separating the application logic and the user interface. To do that, we are going to go to the lib folder, create a new file called counter.dart, and here create a class called counter. And in here, we are going to have all the application logic. For example, I'm going to create a private variable of counter equal to 0. Then I'm going to create a public getter, a count, which will return this counter variable. Why have I done this? This is because I don't want the value of this counter variable to change from outside of this class. For example, if I just go to main.dart, let's import counter class. Alright. I don't want this counter to be able to change the value of this count. So I won't give access to it by making it private and then just put out a getter. Getter won't be able to change the value, right? It will only be able to give a value. That's what I've done right now. And now, whenever we want to change any value, we can do that from inside this class only, because this private variable is accessible only inside this class. So here I'm going to create a function called increment counter. And here I'm just going to increment counter by 1. So counter plus plus. Now I can go to the main.dart file. I'll create a final instance of this counter class. I'll remove this counter variable, there's no need for it. To display the value, I'm going to use this public getter. Also in the set state here, I'm going to have counter dot increment counter. And then I'll call set state so that the build function rebuilds and we see the UI change. I'll scroll down and in the text, I'll add here counter dot count to be displayed. I'll save it. And now if I see, the application works just like before. The only difference now is our code is separated in terms of concern. For example, my UI is different from my application logic. This is good because now my counter class can be tested. If we have this mixed together, it will be very difficult to just test it out. Now let's get started with testing our app. Whenever we want to test something, we have to go to the test folder here. This is the folder Flutter looks for when you start testing, right? You have to give a certain command so that Flutter can initiate the testing process. So this is the folder Flutter goes into. And here we already have a file called widget test. And this test contains everything related to a widget test for this counter application. So let's delete it for now. We'll look at widget testing in the next episode, the widget testing episode. But for now, let's concentrate on our unit tests. So what do I want to unit test? I want to unit test my application logic. There's nothing to unit test in this file, right? We don't want to unit test my app. It's just a UI class. Even my home page is simply now a UI class. We have called certain functions from counter, but all of our logic lives in this counter class. So you want to unit test this counter class. And that's what I'm going to test here. So I'll create a file, call it counter, which is the name of my file, underscore test.dart. This is the naming convention. Whenever you want to test something, you need to add underscore test over here. If you don't add it, Flutter won't get to know that this is a testing file. And when you run the particular command to test a file, it will go to this folder. It will see that no, this counter does not have underscore test. So this is not a testable file. So you always need to put underscore test. It carries a special meaning. And then click on enter. The convention is always putting the file name first of the original file you're testing, followed by underscore test. But of course, if you try to name something else, for example, if you just name this r underscore test and write test for this counter file, it will work. But when the application size increases, it will get a lot tougher because other engineers joining you in this app won't get to know what our test is. That's why convention is to write the file name, but underscore test is convention as well as necessity. Okay, so here we have counter test.dart. Now before starting the test, we always want to make sure that in pubspec.yaml file in the dev dependencies, we have a package known as Flutter test. This package gives us a lot of functions and other utilities so that we can start testing. So let's come to our counter test and let's get started. So the first thing we need here is void main function. Whenever you have a Dart file, obviously you need a main function, which is basically an entrance to your Dart program. And here we are going to start testing. Now let's understand what we need to test. First, let's understand what we want to test. There are multiple things we can test here. First of all is whenever this class is instantiated, the counter class is created. For example, over here, when this counter class was created, we want to check what is the counter variable. So it should always be 0. That's what we want to assure. That whenever the counter class is created, we want this variable, which will be accessible through this count getter, should be 0. The second thing we want to test is that whenever this increment counter function is called, the value of this count should be 1. So these are the two things we need to test. So let's get started. To test, we need to call a method called test, and this test does not have any meaning here, but if you just import something known as the flutter underscore test package, this test is now a function. It does have its meaning, and you see we get an autocomplete. So you always need to make sure that you have flutter test package imported, and then you can call the test function. What are the two things that are required in this test function? First one is the description. So in your app, you can have a lot of features, right? So you always need to give some description of what's happening and what should happen. So the convention followed here is called given, when, then. So let me write it down in the comment section. So we have given, when, then. So we want to tell what's given to us. So given to us is a counter class. When it is instantiated, then value of count should be 0. So we have followed this convention. Basically, what is given to us? Given to us is a counter class, right? We only have access to the counter class. And when it is instantiated, so whenever the counter class is created, then the value of count should be 0. This description can be really anything, but it should always be descriptive. Maybe this isn't descriptive enough for you and your team. Maybe you want to try something else. So you can try anything else which is descriptive, then it's fine. And after this, we have a function. So we have this function here. So these are the two things that are required. First one is the description. This description will only be useful when we start testing our app. When we click on this run function and this test runs, this description will be helpful to us. You'll see that when we run the app. Okay. So for now, let's focus on the function part. What should the function here be? Basically, how do we need to test? We have given the description already, so we know what to test, right? We want to create an instance of the counter and check if the count property on it has a value of 0. So here I'm just going to create final counter which is equal to counter, and then I'm going to have final value equal to counter.count. What I've done till here is basically created an instance of the counter class. This is known as arranging, right? So I've arranged it, whatever things I need before starting the test, I've arranged it. Then I want to act. My act is basically when. Given is basically the counter class. So I've arranged it, which is given. When is basically the act. So my act was just to get the count value, and then is basically assert. Then is assert. So here I just want to check if the value is actually 0. To do that, Flutter test package gives us a function known as expect. So here you just pass in the actual value. So that is this value, what we get from act, and then in the matcher you pass in 0. So I'm expecting this value to be 0. This is what this expect function means. My counter.count value should be 0. So I've passed in the real value that I want to check, and this is the value that I'm guessing it should be, right? Now just to test the app, what I can do is go to the terminal, come over here and type a command known as flutter test and then run it. What it will do is go to the test folder and run all the files related to _test, whatever files have _test in them. And here you see it says all tests passed. Another way to test is come to over here on this tab in VS Code, click on this button here, run tests, and it will run all the tests for us. We have only one test, and if you click over here, it expands, and here is our description, right? Given counter class, when it is instantiated, then value of count should be 0. So this description helps when we have a lot of tests over here. When our app size increases and we have lots of tests, it will keep helping us because we know exactly what passed, and whatever failed, we'll go over there and understand why it failed and then fix our code. So let's close it a little bit. Another way to run it is basically running this run function, and we'll obviously see the output over here. So I hope this much was clear. Now let's write another test just to make sure we understand it even better. So here I'm going to write another test which is given counter class, when it is incremented, then the value of count should be 1, right? Because whenever there is 0, right, here it's 0, increment counter is called and the value should be 1, right? Yeah, given counter class, when it is incremented, the value of count should be 1. So here what will we have? Let's see. Let's put some commas so that we have our formatting. And here we are going to have our arrange, act and assert. Basically like given, when, then. In arrange, I'm going to put my counter class because I don't have a counter class created here, right? Nothing like it exists. So I'll again have to create an instance of counter class. Then we want to act. So what is my act going to be? Well, I want to call the increment function. Here it was just being instantiated. So my arranging and acting was pretty much similar. In my act over here, I'm going to have counter dot increment counter, and then I'm going to get the value, which is going to be counter dot count. And then I'm going to assert by just having expect value to be 1. So I've created an instance of counter class. I'm calling the increment counter method on it, and then I'm expecting the value that comes from here to be 1. Now let's run this test. So let's click over here. Let's come to our testing, and here you can see even this class passed over here. So both of these tests are now working, but there are a lot of things we can change over here. For example, as you can see, these are two tests of the same class, of the same category also. So you want to group them, right? What we can do is basically just group together, like mix together in one thing. For example, the YouTube playlist itself. If I have a state management tutorial, I'm not just putting it like a separate tutorial. I'm putting it in a playlist so that it's grouped together, right? So here I'm just having group, and for the description, I can just put counter class like this. Why have I put a hyphen here? You'll understand when we run the tests again. And now I can just take this test and put it inside of this group. So these tests are now of one category, which is the counter class. Now I can run the main function entirely so that I see something. And here you see test counter test.dart, which is this file, the counter class, which is the group with a hyphen, and then it says given counter class when it is incremented. Okay, so now we have just grouped them together. Why did I want to group them? I told you the reason, but another reason could have been my counter to shift over here. I don't want to keep creating the instance of this counter again and again, right? So I just put it in a group, and now I can remove the instantiation from both of these tests. And now if I save it and run it again, both of these tests pass. But let me show you another problem now. If I go to counter and create a new function to decrement the counter, my apps need to grow, right? So I'm adding a new feature so that a user can decrement the counter. And here I'll have counter minus minus. So I'm just decrementing the counter, okay? And in the UI, you can make according changes, but this is not a UI tutorial, so I'm not going into it. You can add it and call this method over here. It doesn't really matter. I just want to test this function now. So I can create a new test over here. I'll have test given counter class. When it is decremented, then the value of count should be, and what should it be? It should be -1 or 0. It should be -1. Why? Because as I said, unit tests should be independent of each other. For example, if one day I decide to remove the increment feature, only the decrement feature is available, I'll remove this test as well. Okay? And if it's not being incremented, then the value will always be 0, right? And then if we call decrement, it will be -1. So it should always be -1. It should not be dependent on any other test. So even if you remove the test, this test shouldn't get affected. They are independent of each other. So let's bring back this test and here create a function. So again, we need to arrange, act and assert. I already have the arranged part, my counter instance. I want to act, so I'll have counter.decrement counter. My final value is going to be counter.count. And I expect, not expect value to be -1. Now if I run all the tests together, let's see what happens. So I'll go to testing. Here is my new class and you see there's no tick mark option over here because this part has not been tested yet. So let's run all the tests again and see if it works. No, it doesn't. As you can see, our two tests, the previous tests have passed, but this test hasn't failed. So this group test has failed and thus the entire counter test file has failed. Why did this test fail? And here you can see the reason. Expected -1, actual is 0. So what happened here? Let's analyze it from the top. We created a group, then we created an instance of this counter. Okay, now we have this counter and we're using this counter to first check if the value is 0. It is indeed 0, so this test passed. Then we come down here, we increment the counter, and this is the same instance. So the value changed from 0 to 1. So increment counter worked, and thus this test also passed. And then when we came over here, we decremented the counter. The same counter was used, right? The same counter instantiation. This class itself was used. So the value of the count over here is 1 because we have incremented it over here. And when we decrement now, it will be 1 minus 1, which will be 0. That means we are not really independent from this test, because if we remove this test and save our file, run our tests again, now it passes. So since we are using the same counter instantiation, our value of count is also changing. That means my test is dependent on other tests. So what I need to do is basically put back my arrange in the same test. And now if I run the tests again, all three tests have passed. Because everyone has their own counter instantiation. They have a new instantiation created because of which they do not depend on each other. And now if I even remove this or even this test and run my function, it still passes. Alright? But now you might ask, if I have a lot more functions, for example, reset function created as well, does it mean I need to keep creating instance of this counter class? That will be a little hectic, right? And of course, if the app size increases and you have more complex functions, it might become a little tougher to keep writing the code again and again. So for that, what we can do is go to the main function, and here Flutter test package gives us access to some functions which are setup, setup all, tear down all, these 4 functions. There are various stages in testing process as well. There's pre-test, which is setup and setup all. There's post-test, which is tear down and tear down all. And this is basically the testing. So this is pre-test, then testing, and then post-test. What this means is these two functions run before test, then testing occurs, and then these two functions run. Now what's the difference between setup and setup all, and teardown and teardown all? Setup is basically called before every test is called. So when I use setup, what happens is setup is called, then this test is done. Again setup is called, then this test is completed. Again setup is called, then this test is run. And if there are many more tests, again setup will be called and test will be done. What setup all does is basically, first setup all is called, then test 1 is done, test 2 is done, and test 3 is done. So setup is called before every test and setup all is called before all the tests. Let me write it down again. Setup is called before every test and setup all is called before all the tests. Okay? So setup is called before every single test is run, and setup all is like first it will run and then all the tests will follow on. To give you a diagram, here it is. Setup, then test, then setup, then test, then setup, then test. How setup all works is setup all, test, test, test. So I hope this clears the difference. Setup is called before every single test. Setup all is called before all the tests. And similarly, teardown is opposite of it. Teardown is called after every single test and teardown all is called after all the tests. Right? So to give you a demonstration, teardown works like this. First test is called, then teardown, test is called, teardown, test is called, teardown. And in teardown all, test, 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 and then teardown all. So to give you a demonstration, let me copy this. It's like this. Teardown is called after every test. So let's take it from here and put it over here. So we have test, teardown, test, teardown, test, teardown. And how this works is test, 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 and teardown. All. I hope the difference is clear now. And that is why this is called pre-test. This is run before the tests. This is called the testing. And this is called post-testing because it's called after testing. You can, if you're having difficulty understanding it, it's basically like init state, then our UI, and then the dispose part. Similar to it. So let's remove teardown and all of this and understand what we want to do. We don't want to call setup all because that will be just like instantiating the counter class over here because it will run just once before all the tests have been executed. Setup is basically what we are looking for because we want a new counter class to be instantiated for us, right? So here we are just going to have late counter counter, and then we are going to have setup, create a function, and then we'll have counter, which is equal to counter. We have to create an instance over here because this is basically a function, right? If I just put it inside of this, none of the values will be accessible outside. So if I just remove this, counter does not exist. And that's why I have to put this counter outside. And now if I remove it, it still works. Okay? And this should be late. Obviously, if we don't put late, we'll have to make this nullable. And this is obviously not nullable. So we are putting in late because we are sure this setup is going to run before every test. and thus every test is going to have a new counter instance, and thus the tests are not going to be dependent on each other. Let's remove all of the calls from here and let's save it. Now also let's just remove teardown functions. I think we have already moved. Cool. Now let's run all the test files and see if it works. And as you can see, all the tests have passed. If I use setup all instead, it shouldn't run. So let's see if our test fails. If our test fails, we are actually successful. So let's run the task. And here you can see it again failed because it's behaving just like final counter which is equal to counter here. Right? I hope it made sense and I hope it was understandable. If not, let me know in the comment section. Just to test on your own, what you can do is create a reset function and create a test for the reset function itself. That should give you more confidence. So it's kind of like an exercise. You should try it on your own. And just so that you can confirm, I'll do it on my own here. So I have reset underscore counter is equal to 0. Then I'm just going to go over here, create a new test, description given counter class, when it is reset, then the value of count should be 0. And then I'll again call the function here, then I have counter dot reset, and you see I don't have to create a new counter instance again because we have setup here. Also, it should be setup, not setup all. We have setup here, which will run before every test. So we are sure we are going to get a brand new counter instance. And now I can just expect value should be counter.count because I've not stored it in a variable. I just wanted to show you can also put counter.count over here and match it to 0. Because I'm expecting counter.count to be 0. And if I go to testing, run all the tests, it should work for me. And as you can see, it works. And just to see if the tests really fail, what you can do is remove the decrement counter, save it. Obviously, there's an error over here. And if you try to run it, it tells you the errors exist. But even then, if you want to test, maybe you can check if it works properly. So in the decrement counter, you're actually incrementing. Thus, this test should fail. Let's see if it really fails. So let's run. And you see, it really fails. And it says expected was -1. Actual is 1. So you are expecting -1, but actually the value was 1 because you incremented, right? From 0, the value went to 1. But you're thinking you've added the decrement counter. So this is a bug in your app, and to fix it, you just go to the resulting function and add proper fixes. Then again run your tests, and this time it works. So this was the testing of the counter app. This was a very simple and basic example. Now let's look at another example, and that should make things clearer and we learn about something new now. So this is the next tab that we are going to test. What's happening here is an HTTP request is being sent from the app, and whatever data we get, if it's a proper data, then we are converting it to a user model that I've already created here, and then I'm displaying it on the screen using a future builder. So I'm calling the method here, which is this exact method, and displaying it on the screen. I've already separated out the UI and the application logic. As you can see, I've already created user repository where I've created my function, and then I'm just calling it in my UI file. So both application and UI is different. Now let's write a test for the user repository. We don't have to write the test for UI as of now. That will come under widget test. What we want to do is write a test over here for this function, and obviously other functions if we have them in this class. For example, if we want to create a function for deleting a user, we'll add that to the user repository itself. And we'll have to test every function present in the user repository. because we want to check if that works properly. So let's apply our unit testing logic now. We'll go to the test folder and we need to create a new user repository test. Now a shortcut that you can take is, instead of manually typing user repository test ... what you can do here is right click, then click on go to tests, and here you'll get a prompt. If we would like to create a test file, at test, which is this folder, followed by user repository test ... So I'm just going to click on create, and it automatically creates a file for me with boilerplate code. But this boilerplate code is written for widget testing. This is not a test for unit testing. So we'll remove this and create a test function here. So let's have test. And what is our test going to be? Well, it's going to be the user repository class. Because if our application size grows, we are going to have more classes. So first we need to group them. So let's create one group. So we have user repository, and here we'll write our tests. And the test first that we need to write is for the getUser function. So we need to check two conditions. First, we need to check if the response status code is actually 200. If it's actually 200, then we want to return a user. But if it's not 200, we want to check if an exception is being thrown or not. So you want to test two cases over here. That's the most important thing you need to understand before you start testing. What all conditions do you want to analyze? First, I want to see if the response is actually being fetched, and if it is not actually being fetched, if something went wrong. So usually whenever an if condition comes in, you have to check for both those conditions. So what if the 200 status code is not there? We have not unit tested that, right? We have only unit tested for when the status code is 200. So we'll return a user model. But what if status code is suppose 400? That means a bad request. That time we have to check if an exception is being thrown or not. So we need to test these two conditions. So inside a group, I'll create another group here. Why another group? Because I need to test two conditions, and those two conditions are related to just one function, which is the getUser function. So I'm just going to type here getUser function, and all my tests are going to be written related to getUser function inside this group. So yes, we can have nested groups in here. We can have as many groups as we want. We are allowed to have as many ever as we want. So after having the getUser function, so I'll write test, then I'll write given user repository class when getUser function is called and status code is 200, then a user model should be thrown or returned. Because thrown is for exception, right? We usually say this was returned, and thrown is usually associated with the exception or something like that. So return, and then we'll just put this, and here we have it. So what have I written here? Well, we are given a user repository class, and when getUser function is called and the status code is 200. Our next test is related to our status code being something other than 200. So here we are also making sure that the status code is 200, then only a user model should be returned. So this is the test that we are going to do. So let's convert this into a block and write the test for it. So first of all, let's create an instance of this user repository class. And so that I don't have to write it in every single test, what I'm going to do is use setup function. So here we can have late user repository. Then I'll have setup user repository is equal to user repository, just like we saw in the previous example. Now we can take this user repository and then do our arrange act assert. So in the arrange part, what do we want to do? We have done this right here. We have created an instance of the user repository, so nothing as of now. For act, we need to actually call the user repository class. So let's call user repository dot get user, and I'll have to store it in a variable. So I'll have final user is equal to await, because this will return a future. I'm expecting a user model. So if I don't await this, I'll get future user, right? Because that's what the function is returning. I'm expecting user, So I'll just await it. And to await it, I'll have to make this function asynchronous, and test function allows that. And now after having the user instance, I just want to assert that yeah, this is indeed a user model. So I'll have expect user, and in the matcher, what will I put in? Will I put in user? Not really, because I really don't know what the email, name, ID, website can be, right? Because this is being fetched from an external API. What if this is being fetched from your database? Every user will have a different email, password, name, etc. Right? So we can't manually put in some username. Although in this case we can, because we know what the name, username, email and website is going to be. But that's not always going to be the case. So in these cases, what you do is you check if it is a user model that is being returned. If it is indeed a user model, then it will obviously have the right data, because our logic over here is correct, user.fromJSON. So here you can just have is a followed by user model written in this generic type. Okay. So now this is the syntax. We are just checking if this user is a user model, and user model is this class that we created. So you can check if it's actually a user from this, and it will check the return data types of both and confirm if it's actually a user model or not that is being returned. But obviously in this case, another thing you can do is just pass in user with the username, email, password, things that you know, and it should give you the right answer. But in some cases, you just can't have the username, email, name, ID, password, website, whatever. So in those cases, you'll have to use is a. And this is the syntax for it. So let's see if it's working. Let's run this function. Let's go to the testing tab. And here we have it. Our test has passed. Just to verify again, you can run your test again. And it still passes. That means this function is correct. But there are two problems now. If I want to test another function, which is the status code of 400, let's say, how will I test that? So I have test written, then I have given user repository class, when get user function is called, and status code is not 200, because the status code can be 400, 300, 500, whatever, right? And we are treating all of them in the same way. How are we treating that in the same way? Because in the user repository class, we have written if status code is 200, then we return a user model. But if it's anything other than 200, then we are throwing the exception. So if the status code is 300 or 500 or 400, it really doesn't matter. So here we are just typing and status code is not 200, then an exception should be thrown. And if you want to be more descriptive and add what the exception should say, you can just copy this text. Some error occurred exception should be thrown. But I'm not going that descriptive. This much is enough for me. So let's have this test in a block function. And now let's test it out. So we need arrange, we need act, and we need assert. So for arranging part, we have already got the setup function. For act part, we are again going to have final user, which is equal to await user repository dot get user, make this function asynchronous, take this user, and we have to expect if the user is actually returning an exception. So to do that, what you can do is throws exception. So this is one of the matchers that is given by the Flutter test library. Here what you're checking is basically if the user is throwing an exception. But how does that make sense? Because it won't throw an exception. The status code is indeed 200, right? So if I just have this, we'll pass it in. You see, we get an error because it's saying expected is instance of exception. So here we are expecting that it throws an exception, but actually we are getting a user. And that's true, because if this test passed, that means we are actually getting a user. If we are actually getting a user, how can we get an exception, right? Because this test passed, so we are not getting an exception. So this is incorrect. And this is the problem here. we're not able to control the behavior of this HTTP client. We're not able to tell it that, yeah, now the response should be 200, now the response should be 400, now the response should be 500. We're not able to tell it. So we don't have full access to it. Now let me show you another problem. If I just go to my Wi-Fi tab, I'll switch off my Wi-Fi, I'll come over here and I'll run my tests, alright? So I'll run the tests. Now all the functions over here fail. Why is that the case? It tells failed host lookup. It wasn't able to find this, and that was due to no network connection. Obviously, we don't have network connection. How will this run? So it's saying that, yeah, this test failed, but actually this test hasn't failed. It's just that there is no network connection. And as I said before, tests should always be written in isolation. Tests should not depend on any external factors like internet connection. So we need to counter these two problems. To counter these problems, there are packages created. So I'll tell you the two packages that are created for this. First one is Mockito and second one is Mocktail. Both of them do the same task. One of the difference between them is Mockito works with code generation and Mocktail works with us manually mocking the classes. What does mocking the classes mean? Well, basically, let's take example of our user repository class. Our user repository class is being dependent on HTTP plugin, right? That is a dependency. That means our user repository class, our getUser function, is dependent on an external plugin that's not coming from Flutter, which is HTTP package, right? It's not really a Flutter thing. It's an HTTP package that can be found on pub.dev. So our code is now dependent on HTTP, and that's why it's an external dependency. Whenever we have external dependency, we need to get control over them so that we can test them properly. As you could see over here, we didn't have control over HTTP, and thus our tests have failed when the internet connection was gone. So our tests are not isolated. So here, what we are going to do is basically dependency injection. What I'm going to do is take this HTTP plugin. I'm going to import that from the constructor of this user repository class. Of course, you can do it from the parameter of this function as well, but it wouldn't make sense when we have more functions. For example, if we have more functions, suppose this is delete user, this is update user and stuff. When we have more functions, we don't have to manually keep on getting HTTP client from this parameter. And that's why we'll always need it from the constructor of user repository. It's just very easy for us. So I'm going to take this HTTP plugin out and I'm going to inject it wherever needed. Now this won't make sense to you, but wait until I'm done and I'm sure you'll understand. So here we are going to have final http.client, then I take this from the user repository constructor. So we have this .client. Now we can take this client and remove this HTTP plugin and have client.get instead of http.client. So now we are taking it from the constructor and we are injecting the dependency. Where are we injecting it from? We are injecting it from whatever classes we call. For example, let me save user repository. I'll go to main.dart and it asks me that I need to pass in a client. So here I'll have to pass in client and we'll pass it. So you might ask, what's the difference, right? I'm creating a client object here. We are having the same thing in the user repository. How does it make sense? How it makes sense is in the user repository test. Now, even here, the user repository asks for client, but we are not manually going to pass in client like this from HTTP package. What we are going to do here is create a mock of this client. By creating a mock, we'll be able to change its behavior the way we want it to. So to create a mock, first we need to add either of these dependencies, Mockito or Mocktail. If you're comfortable with code generation, you can try out Mockito, or if you just want it very simple, you can have Mocktail. So for this tutorial, I'm just going to go ahead with Mocktail. If you want Mockito example, I'll give it at the end of this section. So let me copy Mocktail and I'll do Ctrl+Shift+P, add dev dependency, not dependency. Make sure you need to add it as dev dependency and then pass in Mocktail. We need to add it as a dev dependency, not a dependency. That's because dependency includes all the plugins or packages that might affect our application, like HTTP. For example, if we do HTTP calls, it might affect our app here. But dev dependencies includes things like linters. So it's not really affecting the app, it's affecting us as developers and makes our life much more easier. That's what mocktail is doing here. It's not really affecting the app, it's affecting the test that we write. So that's why we need to add mocktail to the dev dependencies here. So now let's come back to the user repository test. So let's create a mock client. So to create a mock client, we'll have to go outside of this main function. And here we are going to create a class which will be called mock HTTP client. We are not calling this mock client because mock client class already exists in HTTP package. So you have mock client, it already exists in the HTTP plugin. That's why we are calling this mock HTTP client so that there's no confusion. So let's create mock HTTP client, then we'll implement it with the client plugin or client class that's coming from HTTP plugin. So we have just created a class and we are implementing all the methods, all the properties inside this client class. And this client class is an abstract class which has functions like head, get, post, put, and so on and on. So we are implementing it. But here's the problem. We have to write implementation functions for all of these functions. So we'll have to write implementations for 10 functions over here. So if I just do this, I'll have to write for every single one of them. And then I'll be able to use this mocking class because it's a mocked class. It behaves the way we want it to behave. But that's just too much for us. There's a lot of work to be put to get this mock done. That's why we use packages like mocktail. They help us to mock the class by just extending it. So if I just extend to mock here, we don't have the error anymore. So by extending the mock class, what we have done is basically given all the properties that are required by implementing the client class. Okay, I hope this was clear. If not, let me know in the comment section because it's quite important to understand this. Now let me take this mock HTTP client, put it in the user repository and pass it in like this. It's just like the normal client class. But now we have mock HTTP client. And just so that we use this mock HTTP client over and over again, what we can probably do here is just have late mock HTTP client, mock HTTP client, mock HTTP client equal to mock HTTP client. So now we have instance over here, and if we want to reuse this mock HTTP client, we can reuse it anywhere. Now the behavior is with us, but still if I run the test cases, it will not work. Why will it not work? Because basically I'm just providing the client over here. I've not really given it a behavior according to which it should run. What that means is basically I've created my own class, which is called mock HTTP client. Mock here is just making sure that I don't have to rewrite those functions again. I haven't really set a behavior as to what should happen. So here we need to do something known as stubbing in the arrange part. So here we need to basically tell it that when something happens, this should happen. In our case, what I want to do here is when a client.get is called, that means a get function is called, I want to make sure that I send a response of myself which says this is the data and this is the status code. So what I mean by this is, let me type it out and then you'll understand it better. Here in the arrange, I'm just saying when, and then we have this notation, we have a function here, and we are just saying when mock HTTP client, make sure to use that mock HTTP client, not just client, mock HTTP client dot get function is called, and what is the URL? Well, this exact thing. So let's copy this and paste it over here. So here I'm saying when mock HTTP client dot get is called and when requires a function in the beginning, you'll see this. So I've passed in a function, and when the get function is called and this is the URL, then something should happen. In that case, dot then we want to answer something. And what do we want to answer? Well, we basically want to return a response saying this is the data and this is the status code. So here we can have return response. Then we want a body and a status code. So for the body, let me pass in 3 strings and let me indent this properly. The status code is 200 because here if you see the status code is 200. If you're not understanding, no problem. I'm going to explain it thoroughly, but let me just type it out. And here we'll just pass in the response, which is this thing. So let me copy and paste it over here. I'll indent this properly as well and save it. So we are getting an error now. We are getting this error because the return type response isn't a future response. So when we call the get method, what we get is a future response, not really just a response. So to make this future response, you can either add future.delayed. So you need to wrap this with a future.delayed and pass in the duration, or you can just pass in async to this then answer function. After you do that, the error is now gone. So let's understand what we did. Well, we're just making sure that the behavior is according to what we want. Earlier, we had just mocked the class, but here using that mock client, we are passing it to this when function, which basically alters the behavior of our plugin. Here we are just making sure that we say that when a get function is called using mock HTTP client, and that will be the case when this function is run because that's what we have passed through this constructor, right? Here if you see a user repository class is created, then we are passing in the mock HTTP client, and that mock HTTP client is being used to call a get function. So here we are telling when mock HTTP client.get is called, and this is the URL, then we want to answer with this response. So we are no longer dependent on the data this URI gives us. Okay, we are not at all dependent on what this is. We are only dependent on what we return here. So whenever this get request is called, then we want to answer with this response. Now we can cut short the data obviously because we don't need address, we don't need phone, we don't need company. All this is enough. So we are returning a response. Then this is our response data. And this is the status code that we are passing in, 200. Earlier, we weren't able to pass in the status code, right? Now we are able to pass it in because we are totally in power of what can happen and what cannot happen. Earlier, this wasn't in our hand. Now it is in our hand. So if we want, we can pass in 200 and this thing will help us over here as well. Because here the status code is not 200, I can pass in 400, 500 or anything else. So now we have successfully determined the behavior. So we are just telling when this function is called, then answer this. And then we are calling the getUser function from user repository. So what happens here is this getUser function is called, client.get is called. That client is basically mock HTTP client because that's what we have passed to the user repository class using dependency injection. Then we are having this URI and then we are checking if response.status code is 200. And we have also passed in that this is going to be the response. We have returned a response right here. So we have passed in that the response has a status code of 200. So if status code is 200, it will return a user and we are expecting a user. So let's try to run this case and see if it works. So let's call run function. And here it's saying there's an error. And obviously the error is in over here. This is not a type of JSON. So when we call user.fromJSON over here, it's not really able to identify. So to make this a JSON, you'll have to remove this comma, save it, now run this test. And you see everything is tick mark here. The test has now successfully been run. But this test is still not working. So if you run it, it throws an error, right? So to make this run, again we'll have to mock it. So let's mock the behavior or stub the behavior, not mock. Mocking is this part. Stubbing is basically changing the behavior. So again we'll have when, and then we'll have when mock HTTP client.get, and this is the URL. So let me just copy this, pass it in. When mock HTTP client.get is called, then we need to answer with this. And what do we need to answer with? Well, a response, right? Because that's what mock HTTP client.get is requesting. If I try to return something like a string, it won't be able to accept because the return type string isn't a future response. Because we are basically stubbing the behavior. We are altering the behavior. But by altering the behavior, we are not changing the return data type of this get function. The return data type has to be the same thing. So whenever this get function is called, we'll have to return a future response. So to make this a future response, you can add future.delayed or just make this function async, due to which this becomes a future response. And then you'll pass in response. The body is an empty function because there's an error now, and the error is suppose 500, which is internal server error. So we'll just return that. And a shorter syntax to do this might just be an arrow function. So you can have this, then the return keyword is not needed, and here we have it. So when mock HTTP client.get is called, then we need to answer with this. And now we are hoping it should run. So let's run the entire testing scenario. I'll click over here. Why is the error occurring now? Well, that's because we have awaited this, right? So we have stopped the behavior. That part is cool. Now we are acting, and when we are acting, we are awaiting it. If we await it, it will actually run the function and it will actually throw an exception. So to resolve this, we might have to do try and catch block over here, but that's not exactly what we are going for. We don't really want to catch exception and do anything with it. So here what I'm going to do is await, remove the await, and then it should work. So let me run it again, and it runs successfully. Why did this solve the problem? Well, because if you call user repository.getUser, it returns future of the data type user to us. Thus, it runs the entire function, and when it sees that the status code is not 200, it's 500, it throws an exception. If it throws an exception, this function is like, oh my god, we got an exception. And thus, we need to add try catch block so that we handle that exception. But we don't want to do anything if we have an exception. We just basically want to expect that it actually throws an exception. So if we are expecting that, we remove await because we are not interested in the return data type of the user. We are just interested in if we are getting an exception or we are not getting an exception. So we'll remove this. This is of the type future user, and then we are expecting it will throw an exception. And now just to test it, I'm going to stop my Wi-Fi because I want to test if my testing logic is in isolation or not. So I'm just going to run it again, and you see it still works perfectly. Now our test cases are really in isolation. So if you've understood it till now, you can skip this part. If you've not understood, then I'm just going to give you a brief demo again, and I'll tell you the entire dry run of this. So basically, we have user repository created, then we have the user repository, then we are using user repository.getUser, then we are expecting it, and the same thing is being done over here. But then we realize these test cases are not in isolation. They are not in isolation because our code here at user repository is dependent on an external factor, which is called like an external dependency. So what we are doing to remove that external dependency is injecting it, which is called dependency injection. We're basically injecting the external dependency from the constructor. We can also do it from the function, but constructor is just making it easier if we have more functions over here in this class. Then we are taking this client that we are accepting from the constructor and using that instead of just http.get. Then we resolve the error in the main.dart file. Then we are going to the user repository test and we are creating a mock out of it. To create a mock, we just implement client, but then we realize that we'll have to write 10 more functions for it. So we just add extends mock to it, and when we add extends mock, which is coming from mocktail package, it already implements all the functions that we need. So we don't have to write 10 function blocks. Then we are using that mock HTTP client and creating an instance of it. The same instance is being passed to the user repository class, and the same instance is being used in the arrange part so that we can stub the behavior. Stub the behavior is basically altering the behavior of the HTTP client, where we are saying whenever mock HTTP client.get is called, then we need to answer with this. Just ignore anything else. You'll have to follow what I say in this then answer function. That's what it does. It just says whatever data you get from this, I don't care about that. This should be the response. And based on that response, I'm also able to pass a status code and then check if it's actually a user. Then in the second case, we are again doing that. We are telling when mock HTTP client.get function is called, then you need to answer with a response where we won't get any response because there's an internal server error and the status code is 500. So we are altering the behavior here, and then we are just saying that when we call getUser function, it should throw an exception. We are not using await here, and here we are expecting that whatever the user repository.getUser does, it will throw an exception. And thus our code is now isolated and we are able to test our functions even without connection. So I hope you understood this. This is the most difficult concept people find in unit testing. So you can try and play around with it. I'll mention this code in the GitHub repository below. I would recommend you to implement more APIs, for example, getting articles, getting to-do lists, whatever is present in the JSON placeholder API, and just play around with it yourself. So this is it for this video. Thank you so much for watching, and I'll see you in the next episode of testing series, which is widget testing.